This last example, it's going to reference a different shape. So it's a parallelogram, which has diagonals of lengths 20 centimeters and 12 centimeters. And if the diagonals intersect to form a 60-degree angle, find the perimeter of the parallelogram, right? So there's some properties of parallelograms we need to remind ourselves of from geometry right now. So let's start by sketching a parallelogram. It's just a sketch, doesn't have to be perfect. Okay, so here's my parallelogram. And then I don't know any measurements on the parallelogram other than the diagonals inside the parallelogram. So I'm going to start with that. So let's connect some diagonals. So diagonals are, they connect non-consecutive vertices. So here's one diagonal. I have another diagonal connecting the other two vertices here. Okay. So some of the things you probably need a refresher on is diagonals of parallelograms are not congruent. That's the first thing you have to understand. They may look congruent, but they're not. And the other thing is that diagonals of parallelograms bisect each other. So I know that when the green diagonal hits the blue diagonal, then these two sides of the blue diagonal are congruent to each other, and then these two sides of the green diagonal are also congruent to each other. The problem explains that the diagonal lengths are 20 centimeters and 12 centimeters. So I'm going to use 20 centimeters for my green diagonal because it appears to be the longest. And that would make this side here 10 and this side here 10 centimeters. And then for my blue diagonal, the whole thing measures 12. So that's going to give me 6 centimeters for that piece and 6 centimeters for that piece. The last piece of information is that when the diagonals intersect, right, so those two diagonals intersect and there's 4 initial angles that you can observe right away. It gives us the angle measure of 1, which is 60 degrees. So I'm going to label the smallest angle here as my 60-degree angle. Right? And, you know, this, because vertical angles, that angle measure is also 60. We also know that the other angle, this obtuse angle here, is going to measure 120 degrees, and that's because when those two diagonals intersect, they create linear pair, and the linear pair always sums to 180 degrees there. So we need to find the perimeter. So in order to find the perimeter of this parallelogram, I need to know the side lengths. Right? So let's start. I'll call this side length, you know, it could be anything. I'll call it X for now, and then we'll call this side length Y. So when I look at that information, I'm going to start with one of the smaller triangles. I'll start with the acute. So I'm going to retrace this and work with it on the side. So I'm going to start with this triangle here, and we're going to work with it down here first. And we're going to relabel everything. So this is going to be side X. Side length here measures 10 centimeters. This side length here measures 6 centimeters, and then that angle in between the two side lengths here is 60 degrees. Look at this, that's a side angle side scenario. That's a safe law of sines situation. Excuse me, it's a safe law of cosines situation here. And we need to find that side length of the triangle so we can find that side length of the parallelogram. So we'll use law of cosines. And then in this case, that'll be x squared is equal to 6 squared plus 10 squared minus 2 times 6 times 10 times the cosine 60 degrees here. Again, take your time. It's 36 plus 100 minus 120 cosine of 60 degrees here. So x squared is equal to 136 minus 120 cosine 60 degrees. At this point, I'm going to enter this, the whole right side of the equation in my calculator. So 136 minus 120 cosine 60. That gives me 76 exactly. And to isolate x, take the square root. That'll be x is equal to the square root of 76, or approximately 8.71779 here. I'm going to round this to the tens place, so this is going to say x is approximately 8.7 centimeters right now. So that is one side of my parallelogram, 8.7. I'm going to go back up to my original diagram. And now I'm going to work with the obtuse angle we have. I'm going to sketch this part of the diagram for us to work with. Take it down right here. Start labeling my side length. So remember, from this diagonal, this triangle, we have a 6 centimeter, a 10 centimeter, and a 120 degree angle. This side measures 6 centimeters. This side measures 10 centimeters. This angle here is 120 degrees. Of this side in the parallelogram y. Again, this is a side angle side scenario. So it's a safe scenario to use the law of cosines. And we're going to set it up as y squared is equal to 6 squared plus 10 squared minus 2. 6 times 10 times the cosine 120 degrees here. Again, take your time. 36 plus 100 minus 120 cosine 120 degrees. At this point, we're going to enter that whole right side into our calculator. So 136 minus 120 cosine 120. That gives me exactly 196. And to isolate y, take the square root of both sides. Leaves us with y is equal to 14 centimeters exactly. Now this is side length y. So now I have the two sides of my parallelogram. I'm going to go back up. Right. So now I know that side length y is equal to 14, and that side length is 14 centimeters. Side length x was 8.7 centimeters. Here is 8.7. The perimeter of this parallelogram is the sum of all four sides. So we're going to take the sum of all four sides there. So that's 14 plus 14 is 28, and then plus 8.7 plus 8.7. That gives us 45.4. That is the perimeter of our parallelogram. Okay, so this is one specific example that deals with parallelograms where it gives us our diagonal side lengths. Keep in mind, some of the questions may ask you to actually find the diagonal lengths of the parallelogram instead of the perimeter there. So one thing you want to remember is that the diagonals of a parallelogram are not necessarily congruent. If it was a rectangle or a square, yes, but standard parallelogram, those diagonals aren't necessarily congruent, but they do bisect each other once they intersect. So keep that in mind.